So here's the solutions video to the absolute value inequality homework. Okay, even though it's multiple choice, remember I told you you have to show your work on a separate piece of paper. Okay, you have to show your work on a separate piece of paper. You don't get credit if you just go through and circle a choice. But the good news is that you only have to do the odds. So let's look at number 1. I wanted the absolute value of x minus 3. Whoops. X minus 3 to be less than 5. Okay, remember, anytime we have a complicated absolute value, we always treat it like an equation so we can get our points on our number line, and then we'll just use test points to figure out where to shade. So let's change this to an absolute value equation. And we've been working with absolute value equations for about a week now. We break it into the two cases. So x minus 3 equals 5, or x minus 3 equals negative 5. Solve for x, you get that x is equal to 8, or x is equal to negative 2. So those are what I'm going to put on my number line. Negative 2 and an 8. And if I look at my inequality up here, there's no equal bar, so these are going to be open circles. Okay? So looking at the multiple choice possibilities, are there any that we can get rid of right now? Nope. Okay, so they all have a positive 8 and negative 2 in there. So now let's do some test points. All right, I'll do negative 3, I'll do 0, and I'll do 10. Remember, we check in the original, so we're checking in the absolute value inequality. So that's going to be negative 3 minus 3. That gives me negative 6. And the absolute value of negative 6 is positive 6. This does not work, so we do not shade there. Now let's test 0. That gives me negative 3 on the inside. The absolute value of negative 3 is positive 3. And 3 is less than 5, so woohoo, we are going to shade in the part that has 0. When I test 10, that's going to give me 7. The absolute value of 7 is 7. That does not work, so we do not shade. Okay, and remember, the quick trick is that if I have a less than, I'm always going to be smushed. Remember, great ors look like ors, less thans are smushed. So if we look at our choices, I need to be bigger than negative 2 and less than 8. Bigger than negative 2. X has to be bigger than negative 2 and less than 8. That's going to be choice 3. No. Yes. All right. Bigger than negative 2 and less than 8. Now on to number 3. 3, we had the absolute value of x plus 3 is less than or equal to 5. Let's make it an equation, figure out what's going to be on our number line. So I've got x plus 3 in absolute values is equal to 5. Break it into the two cases. X plus 3 equals 5, or x plus 3 equals negative 5. Solve for x, I get x is equal to 2, or x is equal to negative 8. So those are what I'm going to put on my number line. Negative 8 and 2. And if I look up here, I do have an equal bar, so these are going to be filled in circles. Okay, now looking at my choices right now, I can automatically get rid of choice 2, and I can get rid of choice 4. Okay, because choice 2 has negative 2 and positive 8. I don't want that. And so does choice 4. So I can get rid of 2 and 4 automatically. Now, let's do some test point work. Here I'll test negative 10. Here I'll test 0, and here I'll test 3. Remember, we check in the original. Let me extend. Boop. So this is going to give me the absolute value of negative 10 plus 3 is less than or equal to 5. And then this is going to be negative 7. And the absolute value of negative 7 is 7. This does not work, so I don't shade. When I plug in 0, I get the absolute value of 3, and that's 3, and 3 is less than or equal to 5, so that does work, so I do shade where 0 is. And then when I test 3, I get the absolute value of 6, which is just 6, and 6 is not less than or equal to 5, so I don't shade there. Okay, and we can check to see that it was right because I had a less than, and a less than should be smushed. So I need to be bigger than negative 8 and less than 2. That's going to be choice 1. Okay, and also kind of a giveaway because if you look at choice 1, the x is smushed between the 2 and the negative 8. Okay, so lots of hints of which one's right. On to number 5. Now we wanted, so now we wanted the solution of the absolute value of 2x minus 3 is less than 5. Okay, let's turn it into an equation to figure out what's on our number line. And now that it's an absolute value equation, we can break it into the two cases. So I get 2x minus 3 equals 5, or 2x minus 3 equals negative 5. This will give me 2x equals 8, so x equals 4. Or this will give me 2x equals negative 2, so x equals negative 1. That's what I'm going to put on my number line. Here's negative 1, here's 4. There is no equal bar, so it is going to have open circles. Okay, and now let's do some test points. Down here, I'll test negative 2. Here, I'll test 0. And here, I'll test 5. Okay, so and I test in the original. So this is going to be 2 times negative 2 minus 3, which is going to give me negative 4 minus 3, which is negative 7. And the absolute value of negative 7 is 7, and 7 is not less than 5. So that one does not work. And I can fit all that in there? Nope. Now let's test 0. I'll draw a line here. So that's going to be the absolute value of 2 times 0 minus 3. 2 times 0 is 0, so that's just minus 3. And the absolute value of negative 3 is 3, so 3 is less than 5, so woo, I shade here. Now let's test 5. Woo. So this is going to be 2 times 5 minus 3. That's going to give me, what is going on? 2 times 5, that's 10. That's going to be the absolute value of 7. And as we previously discussed, 7 is not less than 5. So we are not going to shade there. So my x's are stuck between negative 1 and 4. So that is going to be choice 2. On to number 7. This is the absolute value of 3x plus 6 is less than or equal to 30. I'm just going to see how I'm doing on time. Okay. Boop, boop. So let's make it an equation to figure out what's on our number line. So make it equal to 30. Now we can break it into our two cases. So 3x plus 6 equals 30. or 3x plus 6 equals negative 30. Let's solve for x, so I'll subtract 6, so that gives me 3x equals 24. So x is equal to 8. Or I get 3x is equal to negative 36, because it's negative 30 minus 6. And then I divide by 3, and I get x is equal to negative 12. So those are what's going on my number line. And I do have an equal bar in my original inequality, so I am going to have filled in circles here. Okay, now looking at this, I know that it's a less than, so I know that I'm going to have to be smushed. Okay, and I'm smushed between negative 12 and 8, so my guess is that it's going to be choice 1. All right, but you should show the work, because I told you to, but also that's how you can get partial credit if you make a mistake. So how would I test negative 15? Why not? Let's test 0, and let's test 10. And I'm checking in the original inequality. So this is going to be, whoop, almost dropped my calculator. The absolute value of 3 times negative 15 plus 6. 3 times negative 15 is going to give me negative 45. Yep. Plus 6. And negative 45 plus 6 is going to give me negative 39. And the absolute value of negative 39 is just 39, and that is not less than or equal to 30, so I'm not going to shade over there. Testing 0, that's going to be 3 times 0 plus 6. That's just 0 plus 6, which is 6. And 6 is definitely less than or equal to 30, so I am going to shade here, which is good, because that's what I thought I was going to be doing. And now let's check 10. That's going to give me 30 plus 6, which is going to give me 36. And the absolute value of 36 is 36. And sadly, that is not less than or equal to 30, so it's not going to work. So I was correct. I'm smushed between negative 12 and 8, so that is going to be choice 1. On to number 9. Number 9, we are looking for the solution of the absolute value of 2x minus 1 is less than 7. Let's change it to an equation. So the absolute value of 2x minus 1 is equal to 7. Now let's break it into the cases. 2x minus 1 equals 7. Or 2x minus 1 equals negative 7. Let's solve for x. This is going to give me 2x equals 8, or x is equal to 4. Or 2x equals negative 6, so x equals negative 3. That's what I'm going to put on my number line. And there's no equal bar, so these are open circles. And it's a less than, there are a lot of less than, so I'm pretty sure it's going to be smushed, but let's do the work. And for test points, I will pick, how about I pick negative 4, I'll pick 0, and I'll pick 5. And I test in the original. So this is going to be 2 times negative 4 minus 1. It's a horrible less than sign. So that's going to give me negative 8 minus 1. That's going to give me negative 9. And then that's going to give me 9. That does not work. That's going to give me 0 minus 1, so that's negative 1. And the absolute value of negative 1 is 1. Yay, that does work. So I do shade in the middle. And now let's test 5. That's going to give me 10 minus 1. That's going to give me 9. And 9 is not less than 7, so I do not shade there. So I need to be smushed between negative 3 and positive 4. So let's see, since I'm smushed, I know that it's got to be an and. So I can't be choice 1 and I can't be choice 2. Okay, now let's look. Is x smushed? Now, choice 3's got a negative 4, so that's not right. So it's got to be choice 4. All right, so we are at choice 4 for this one. Dos más. 11 and 13. For 11, oh, finally, a greater than. So we've got the absolute value of 4x plus 8 is greater than 16. Okay. Now looking at this, it's got a great or, so I need to have an or in it. So I need to be on one side or the other. Think of the boat picture. Okay? But let's do the work. So I'll make it an equation. And now I can break it into my two cases. And let's solve for x. So here I get x equals 2. Now negative 16 minus 8, that's negative 24. So I get negative 6. Okay. Throw it on a number line. There is no equal bar, so I have open circles. And let's pick some test points. I'll pick negative 10, 0, and 10. All right, 10s are kind of nice to work with. So let's test negative 10 in the original. So that's 4 times negative 10 plus 8. That's going to give me negative 40 plus 8. Negative 40 plus 8, that's a negative 32. And the absolute value of negative 32 is positive 32, and that's definitely bigger than 16. So I'm going to shade over here. Now let's test 0. I'll draw a line. So it's going to be 4 times 0 plus 8. 4 times 0, that's just 0. Plus 8 is 8. And 8 is not bigger than 16, so we do not shade there. Whoop! What just happened? There we go. And now let's test 10. That's going to give me positive 40 plus 8. So I get 48. And the absolute value of 48 is 48, which is definitely bigger than 16. So I am going to shade over here, which is what I thought it was going to be. Because a great or, you know, if you drew the boat, it should look like you got oars in the water. So I am less than negative 6 or bigger than positive 2. Okay, so automatically I can eliminate choice 1 and 2 because that x is smushed. I need an or. And I'm less than negative 6, so it's got to be choice 3. Choice 4 doesn't even have the right numbers in it. Okay, so this is choice, what did I say? Choice 3. Last one. Oh, I see fractions. Do I cry? No. Why? Because I love fractions. So we've got the absolute value of 3 minus 2x. Oh, yay, another greater than or equal to 4. All right, let's make it an equation. Then let's break it into our two cases. So I get 3 minus 2x equals 4, or 3 minus 2x equals negative 4. So this gives me negative 2x is equal to 1, or x is equal to negative 1/2, or negative 2x is equal to negative 7, or x is equal to positive 7/2. Remember, a negative divided by a negative is a positive. So here's my negative 1/2. Here's my 7/2. There is an equal bar, so these are filled in. Okay. Now, if you might be like panicking of how do I pick test points when there are fractions. Okay, negative 1/2 is kind of easy. You could pick negative 1. All right, we got to be more negative. But if you're not sure, then just pick something that is absolutely going to be there, like negative 10 or negative 100. Okay, be smart about what you pick. But I'll just pick negative 1. Because that's definitely less than negative 1/2. In the middle, I can pick 0. Now, 7/2, if you put that in your calculator and you get a decimal, you're going to get like 3.5. So I need to be bigger than 3.5. But like I said, if you don't know that, just pick something obvious. Like I'll pick 10. Okay? So now let's test these. And since it's great or, I should be on either side. It should look like an or. So let's look. Test in the original. So that's going to be the absolute value of 3, a minus, that's going to become plus 2. Oops. Got ahead of myself. And that's going to be the absolute value of 5. The absolute value of 5 is 5, and that is greater than or equal to 4, so I am going to shade over here. Now let's test 0. That's going to give me 3 minus 0, so it's just 3. And the absolute value of 3 is 3, but 3 is not greater than or equal to 4, so I do not shade there. And then I'll test 10. Now 3 minus 20 is going to give you negative 17. But then we take the absolute value and you get positive 17, and 17 is definitely greater than or equal to 4. So I do shade over here, which makes sense because for a great or, I need to be on either side. Or is in the water, you're not smushed. And then if we look, I can definitely not be choice 1 or choice 2 because those are smushed. And I want to be less than negative 1/2 and greater than 7/2. So it's got to be choice 3 then. All right, and if you look at choice 4, it doesn't even have, oh, it does have the right numbers. But that also has an, yep, okay, it has an or, but it says that I'm less than 7/2, so that's not right. So it's got to be choice 3. Okay, remember, even though it's multiple choice, you got to show all this